Hello, all students of EES 512 course. This tutorial is designed for two important goals. First, to understand important concept in lecture by solving some questions, and second, to promote your skills for solving any practical circuits in future. This tutorial is organized as three parts. Part 1 or tutorial 1 covers chapter 1 and 2. Tutorial 2 covers chapter 3, and tutorial 3 covers chapter 4. I'm going to start tutorial 1. Tutorial 1 is designed as two parts. Part A and Part B. Part A supports divided voltage and divided current rules, and Part B investigates KCL and KVL rules. I want to start Part A, question 1. This question describes divided voltage rule. In this question, we want to find out V1 and V2 and V3 in this circuit. We have 20 volts here, and we have 5 ohms, 15 ohms, and 20 ohms here. The goal is to find voltage here V1, voltage here V2, and voltage here V3. We have two alternatives to solve this question. Alternative 1 is to use Ohm's law, and alternative 2 is to use divided voltage rule. Let me explain divided voltage rule, and after that we can use this rule for solving this question. As you know, in any series circuit like this, we have R1, R2, and Rn here, and also we have input voltage or total voltage here. We want to find out V1 and V2 and Vn here. Okay, as you know, any series circuit would be supported by three important rules. Rule 1 says we have same scenario for current. We have current here I1, I2, and In. Rule 1 says we have I1 is equal to I2 and is equal to IN. Rule 2 says total voltage or input voltage is equal to summation of all divided voltage, like this. And rule 3 says equivalent resistance is equal to summation of all resistance, like this. And also in series circuit, we have divided voltage rule, which means we can find out V1 and V2 and Vn for a simple way. For V1, we have V in here, R1 plus R2 plus Rn. Again, for V2, we have same scenario, R1 plus R2 plus Rn. And for Vn, again, we have same scenario, V in plus V plus divided R1 plus R2 plus Rn. Only for V1 here we need R1, for V2 here we need R2, for Vn here we need R1, Rn. In order to summarize and memorize this rule, you can see this part is the same as this part for V1, V2, and for Vn. We have same part for V1, V2, and Vn, and only we need use for V1 R1, for V2 R2, and for Vn Rn. Now I'm ready to use this rule for solving this question. This rule says, for example, for V2, we have here 20 volts, and here we have 5 plus 15 plus 20 times 15. And for V3, again, here we have 20, 5 plus 15 plus 20 times 20. And for V1, here again we have 20, 5 plus 15 plus 20 times 5. And final answer for V1 is equal to 2.5, for V2 is equal to 7.5, and for V3 is equal to 10 volts. Important note, how we can estimate and check our answers. It's easy and important. Our answers should be verified this rule, which means our answers should be verified this equation. 20 here total voltage is equal to V1 plus V2 plus V3. And you can check our answers verified this equation. 2.5 plus 7.5 plus 10 is equal to 20. That's why we are in the right direction to solve this question. Okay, to summarize, we can use divided voltage rule in any series circuit. And immediately we can find out divided voltage, and to check our answers we can apply rule 2, which says total voltage should be summation of all divided voltage. Okay, next question describes about divided current rules. Question 2. In this question, we want to find out current I1 and I2 in this circuit. Here we have 2 amps and 10 ohms here, and we have 20 ohms here. We want to find out current here I1 and current here I2. Again, to solve this question, we have 2 options. Option 1 is to use Ohm's law, and option 2 is to use divided current rule, which is very important to apply for any circuit. Let me explain about divided current rule. If we have input current here and we have R1 and R2 here, and here we have I1 and here we have I2, divided current rule says we can find out I1 and I2 immediately by using this formula. I1 is equal to input current divided R1 plus R2, and for I2 we have same scenario again. I in divided R1 plus R2. Only for I1 we need here R2, and for I2 we need here R1. In order to summarize and memorize these rules, you can see this part for I1 and I2 is the same. And only for I1 we need here R2, and for I2 we need here R1. And also let me explain about parallel circuit scenario. In parallel circuit scenario like this, we have n resistors which connected together parallel like this, and we define here I1, I2 and IN, and also we are defining here V1, here V2 and here Vn. As you know, 3 important rules support any parallel circuit. Rule 1 says we have same scenario for voltage, which means V1 is equal to V2 and is equal to Vn. Rule 2 says total current or input current is equal to summation of divided current like this, and is equal to I1 plus I2 plus IN. And rule 3 says equivalent resistance should be found from this equation. Okay, important note, if we want to use divided current rule, we should change any circuit, any parallel circuit, to only this circuit, which consists of only two resistors which connected together parallel. I mean, if we have more than two resistors which connected together parallel, we should change the circuit to this circuit. And after that, we can use from divided current rule. And other important note, if only we have R1 and R2 which connected together parallel, for two resistors R is equal to R1 times R2 divided R1 plus R2, which means this equation should be simplified to this equation only for two resistors scenario. Now we are ready to use divided current rule for solving this question. For this question, I1 and I2 is equal. I1 total current is 2, 10 plus 20 here, and again for I2, 2 here, 10 plus 20 here, and only for I1, here is R1, here is R2. For I1, here we need R2 20, and for I2, we need R1, here 10. And the final answer should be 40 over 3 and 20 over 3. Okay, how we can estimate and check our answers? It's easy and important. Our answers should be verified this equation, which means in this question, 2 amps total current is equal to, should be equal to I1 plus I2. You can see our answers are right, because 40 over 3 plus 20 over 3 is equal to 2. That's why we were in the right direction to solve this question. To summarize, we can use divided current rule for any parallel circuits which contain of two resistors connected together parallel. For more than two resistors, we should simplify network or circuit to this circuit. And after that, we can use divided current rule. Next question, investigate equivalent resistance. Question 3. In this question, we want to find out equivalent resistance in this circuit. Here we have 10 ohms. Here we have 40 ohms and 40 ohms. And here we have 10 ohms. And here we have 20 and 20 ohms. Here we have A, and here we have B. That's why equivalent resistance also calls RAB. Okay, important key to solve any circuits like this is to diagnose about series and parallel resistors. In this circuit, this 40 and this 40 parallel, and this 20 and this 20 connected together parallel. And we can simplify circuit to this. We have 10 here, and 40 parallel to 40 should be 40 times 40 divided 40 plus 40 should be 20. This is a simple rule. 40 parallel to 40 should be 20. 20 parallel to 20 should be 10. Here we have 20 ohms. Here we have 10 ohms. And here 20 parallel to 20 should be 10 ohms. Now it's clear. Equivalent resistance should be this resistance 10, series 20, series to 10, and series to this 10. 10 plus 20 plus 10 plus 10 is equal to 50 ohms. This is final answer for equivalent resistance. Important question. If we have here open circuit, here we have open circuit, what happens for equivalent resistance? I mean, if we have open circuit, how we can find out equivalent resistance again? It's easy for using two important rules for open circuit. Any open circuit has two rules. Rule 1 says current for open circuit should be 0, and makes sense because we have here open circuit and there is no current. Rule 2 says equivalent resistance for any open circuit should be infinity, and again makes sense because if we have current 0, equivalent resistance should be infinity. Okay, now equivalent resistance is equal to infinity plus 10 plus 20 plus 10 plus 10. 10 plus 20 plus infinity plus 10 plus 10, and total equivalent resistance should be infinity. Next question describes about short circuit. Question 4. Again, in this question, goal is to find equivalent resistance. In this circuit, we have 10 here, 20 here, 30 here, and 40 here, and 50 here. And important aspect of this circuit is to have short circuit here. We have short circuit here. And we want to find out equivalent resistance or RAB. Important key for this circuit is short circuit. Any short circuit would be supported by two rules, 1 and 2. Rule 1. Voltage for short circuit is equal to 0. And it makes sense because there is no any resistors here. And rule 2 says equivalent resistance should be 0. It's easy and important to solve circuit like this. That's why if we have current here I, the current here should be 0 and current here should be 0 and the current here should be I. That's why we can say we have no current here and also no current here. It means short circuit bypassed all of the resistors which connected parallel to short circuits. That's why we can say these resistors should be bypassed and this resistor should be bypassed. And the circuit changed to this circuit. And finally, we can find out equivalent resistance. Here we have 10 ohms, here we have 0 ohms, and here we have R equal is equal to RAB. That's why R equal is equal to 10 ohms. To summarize, short circuit can bypass any parallel resistors which connected to short circuit parallel, and the current for any parallel resistors with short circuit should be 0. Okay, now we are ready to start part B of tutorial 1. This part investigates important rules KCL and KVL. Let me explain about KCL and KVL. We can use KCL and KVL together for solving any circuits, which means for using KCL and KVL together, we can find out equations, for example, 1, 2, 3, and so on equations. And after solving these equations, we can find out unknown. For example, all of the voltage V1, V2, and all of the current I1, I2, and so on. Again, KCL and KVL together could be solved any circuit by obtaining equation systems, and after simplifying and solving equation systems, we can find out unknowns. Question 1. In this question, we want to find out V3 by using KCL and KVL. The circuit is, here we have 10 volts, here we have 35 35 ohms. Here we have 70 ohms, 30 and 40 ohms. V3 is defined voltage here. Okay. For solving this question, again, we have two alternatives. Alternative one, we can simplify 30 and 40 because 30 and 40 are connected series, and total is parallel to 70, and total is series to 35. And for using Ohm's law, we can find out current and voltage. The second alternative is to use KCL and KVL. Now, we want to start with defining current, and after that, loop. Okay, important note. If we have current here I1, and also we have current here I2, KCL says the current here is equal to I1 minus I2. Again, we are applying KCL in the circuit. It is very easy and simple if we apply KCL in the circuit. We define here I1, and also here we have I2. That's why KCL says this current is equal to I1 minus I2. And for this current, we have positive, negative here, positive, negative here, positive, negative here, and positive, negative here. Important question. In order to solve this circuit, only we need to find out I1 and I2. I mean, this circuit has two unknowns, I1 and I2. If we can find out two equations in terms of I1 and I2, immediately we can find out I1 and I2. How we can find out two equations is easy. We can define loop A here and loop B here. By defining two loops, we can determine two equations. Okay, equation 1 is obtained by applying KVL in loop A. KVL says in loop A minus 10 plus 35 times I1 plus 70 times I2 is equal to 0. Again, we are applying KVL in loop A. KVL in loop A says we have minus 10 here, plus 35 times I1 plus 70 times I2. This is my first equation. KVL in loop B says minus 70 times I2 plus 30 times I1 minus I2. Important note, the current for 30 is I1 minus I2. Plus again 40 times I1 minus I2 is equal to 0. Okay, right now it's clear. We have two equations in terms of two unknowns. In order to clarify, KCL and KVL can determine equation systems for finding unknowns. After simplifying, the final answer is for I1 is equal to 0.14, and for I2 is equal to 0.75 amps. Now we are ready to find out V3. Important goal of this question. V3 is equal to 40 times I1 minus I2. And final answer is equal to 2.8 volts, because we have I1 and I2 here, and we can find out V3. This is final answer for V2. This is final answer for I1. This is final answer for I2. To summarize, KCL and KVL can be applied together to any circuit to determine equation systems. By solving this equation, we can find out any unknowns. We can find out any voltage, any current, any power, and so on. Next question again covers KCL and KVL. Question 2. In this question, we want to find out V2 by applying KVL and KCL in this circuit. We have 5 volts here, 10 ohms here, 5 ohms here, 2 ohms here, and 2 amps here. The V2 is defined here, V2. Okay. In next tutorial, we will solve the question like this by node and mesh scheme. But now we want to solve this question by applying KCL and KVL rules. Okay. Again, we are defining current here like I1. And we have current here 2 amps. KCL says this current is equal to I1 plus 2 amps. Again, here we start with defining I1 here. And also here we know the current is 2. KCL says in this node I1 plus 2 consists the current of 5 ohms. And immediately we can determine positive and negative here, positive and negative here, and positive and negative here. Now it is very important. This circuit has only one unknown. Unknown is I1. In order to find out this unknown, only we need one equation. We need one equation. And for this reason, only we need apply KVL in this loop. For example, loop A. KVL in loop A says minus 5 plus 10 times I1 plus 5 times I1 plus 2 is equal to 0. Immediately we can find out I1 is equal to minus 3. This is I1. Now, in order to find out voltage across of 5 ohms V2, we need first find the current of 5 ohms. The current of 5 ohms is equal to I1 plus 2 and is equal to minus 1. That's why we can say V2 is equal to 5 times minus 1 is equal to minus 5 volts. This is final answer for V2, for I1, and for I5. Okay. Important note for uh, 5 ohms and for this positive and negative, we have voltage minus 5 volts. If we change the positive and negative for 5 ohms like this, positive and negative, voltage here should be 5 volts. It's easy and important to explain about negative and positive voltage. Once again, for this positive and this negative, voltage across of 5 ohms should be minus 5 volts. If we change the positive and negative like this positive and negative, voltage across of 5 should be 5 volts. In next tutorial, our plan is to investigate node and mesh procedure by solving important question about supernode and supermesh to covers any circuit which we want to solve by node and mesh schemes.